Good morning, everybody. Great pleasure to be here. Thoroughly enjoyed yesterday. There's lots for you to go and see, so I'm not going to hold you here for many minutes. The sustainability thing, it really is right firmly front and centre at this point in time. And for me, there's three key bits to that. One is the weather, which we can't do a huge amount about. One is the soil, which we're pretty good at managing, and there's a little tips and tricks that we can get into to make it work a little bit better. The thing that links it all together is the genetics, the variety. And this is where, like Tim has just said, the agronomist comes in. It's all about picking the right variety for the right point in rotation, and then making sure it's got the right little bits of food and crop protection that keep it going. There's no real point in choosing a really good variety that's got a little bit of a weakness. For example, it's particularly susceptible to BYDV, and then putting it in early and watching it go yellow in the autumn. We'd be looking at saying, okay, if you've got the opportunity for early application and early drilling, you might want to pick a variety, maybe a hybrid, that's got BYDV resistance. My next question would be, how do we make that wonderful trait last longer? And it might be, for example, that we give the plant a little bit more magnesium as it's growing. That magnesium would reduce the food availability for your aphid, and it might just mean that your plant's working a little bit better to keep itself fit, clean and healthy. But that magnesium would also help the plant pick up water and handle nitrogen better. And the sustainability criteria that you're seeing in your guidebook, very important. We've got to have varieties that are yield secure. They've got to be robust, they've got to be good performers. They've got to be efficient with nitrogen. If we do a carbon footprint on this plant here, probably 3/4 of its carbon footprint is all about the nitrogen that we put on to grow it. And if you think about the Diageo Guinness project, you may have seen some of that in the press, the sort of March time. It's all about how do we produce a quality malt that goes into a world-recognized brand using the very best of genetics, using the very best of what we understand in terms of Irish soils and Irish weather. And a lot of that is going to be nitrogen use efficiency. And we've got good varieties that put a lot of effort into root development, keep fit and clean and healthy, and then add appropriate agronomy to that. Choosing a variety that's got good disease resistance doesn't mean we don't feed it and protect it. One of the big things about maintaining genetic traits is that we use appropriate agronomy to harness those traits, get the best out of the plant, but keep that going forward. So we're more yield secure, we're more sustainable, we drive things better into the future. And that for me is what we're demonstrating here. What we're seeing here is all about getting the right genetics, fitting the right plant to the right point in rotation, and then feeding it appropriately. You've got some fantastic stuff here. Very impressed.
So Neil, taking it a step further then in terms of reducing carbon, and that's what you're involved with in the Diageo project. I mean, what other agronomic tricks or tips are going to be, or something, are the things that we're going to be looking at? So let's say if somebody says to you in the morning, I'm growing malt and barley and I put on a fungicide, I put on 2 fungicides, an aphicide, I put on 125 or 30 kgs of nitrogen, I plough, till and sow, and I harvest it, and then I transport it 7 or 8 miles. What are the key, we'll say, aspects of carbon in that life cycle of that barley?
Well, your carbon footprint from there is really coming from your fuel, fungicides, fertilizers. The big bit is fertilizers. So anything we can do to improve the timing and the uptake. So it's a little bit like you're doing with the oilseed rape, the green area index. Watch what the crop actually needs and see if we can get the timing right for that. Because the biggest bit of the carbon footprint is the bit of nitrogen we apply that the plant doesn't pick up. That goes through the soil profile, comes back as nitrous oxide. That's the biggest bit we've got to work with. Nitrous oxide. And that's product choice, product timing, soil conditions. Now, we play with the genetics, and we say, feed the crop a little bit of phosphorus, build its root mass. Maybe look at a seed treatment that primes it below the ground, and then manganese, magnesium on the canopy, make the plant as efficient as possible in terms of water uptake, nitrogen uptake, and that can have a big impact. Then you start to talk about product choices and fitting that off.
So it's basically getting more from less.
We've got to get more efficient, and it's
Okay.
the genetics allow us to do that. What you've got with your hybrid programs and your conventional breeding programs, you're improving the efficiency in terms of disease resistance and nutrient uptake. You're measuring that as yield, but your yield is influenced by, for example, soil moisture, climate, rainfall, sunlight, and you're actually selecting for the varieties that cope better.
Okay.
And that's really quite important, because we will see, I think, changes in things like disease pressure, aphids, because the climate is creeping up in terms of its warmth. That's going to put pressure on varieties that don't have, for example, VYPV resistance or tolerance.
It's not always this warm like in Ireland. But anyway.